So just summarize the formulas. So thrust in terms of simple format, m dot dv rho av v2 minus v1, and blade velocity we can write it as v1 plus v2 by 2 or v1 into 1 plus a. Then slipstream velocity, it is v1 into 1 plus 2a. Then in this thrust formula, assume you know only free stream velocity and slipstream velocity. We don't know the blade velocity. In that case, you can take this formula. Okay, instead of blade velocity, I can write v1 plus v2 by 2. So this formula you can take it in the problems. Or if you don't know v2 also, then you can take this term 2a rho a v1 square 1 plus a. So depends upon the given parameter, we can use these formulas. Okay, it can be this thrust or this thrust formula or this one, anything you can take it. The efficiency also you can take in terms of velocity or a. Okay, so here they mentioned our output is TV1, our input is TV in another form of efficiency. These are the formulas we discussed. Whether we are going for the problem. So here they mentioned a propeller is required to develop a thrust of 4000 Newton. So thrust is given at a flight speed of 120 meter per second at sea level. So velocity, free stream velocity is given. Sea level meaning you know what is the density. Okay, but here they are different velocity densities. Okay, and propeller dia they mentioned. With that we have to find power required and efficiency. Power required is power input, and the efficiency we have to find it. So we know thrust, we know free stream velocity, we know density, and we know diameter of the propeller. Once you know the diameter, we can find the area of the propeller, actuator disk, pi d squared by 4. Now tell me which formula we can use it. Hello? For example, power input, can you tell the formula? Hello?
Yes, sir.
Tell the formulas for power input. So just now we discussed, for example, you can take this TV. Okay, I can take this TV. Again, this V is unknown, right? Because they have mentioned only V1. Then how to convert this? How to further proceed? So power input, thrust into blade velocity. Again, blade velocity is not known. So instead, I can take V1 plus V2 by 2. Okay, I can substitute here. So power input is, thrust is given, it is 4000 Newton. Instead of V, I can take V1 plus V2 by 2. So V1 is given 120 meter per second. So V2 is unknown. So if you want to find the power input, you should find the V2. Then second formula, if you take efficiency formula, so 2V1 divided by V1 plus V2. So we know the V1 120 meter per second, V2 is unknown. So if you know this V2, you can find both the parameters. Okay, then to find this V2, I am taking the thrust equation. So T is equal to rho A V V2 minus V1. Again, this V is not known. So instead of that, I am taking V1 plus V2 by 2 is equal to thrust. So here you see, we know what is thrust, 4000 Newton, density is 1.12, area also we found from the diameter, V1 is given, then from this equation we can find the V2. Is that clear? Density is given, from the dia we found the area, V1 is given, thrust also known, from there we can find the V2. Then substitute here, you can find efficiency and power input. Is that clear, the procedure? Is that clear? So this is one method. Then second method, same formula. A minute. Yeah. So initially I have taken V in terms of V1 plus V2 by 2, right? Or instead you can take this blade velocity into V1 into 1 plus A, but the unknown is A here. Similarly, efficiency formula also 1 divided by 1 plus A is the unknown. So that A we can find it from the thrust equation. But here you have to take different thrust equation. 2A rho A V1 square 1 plus A. We know density from the dia, we know the area. V1 also known. So you can find the area. Thrust also known, you can find the inflow factor. Then substitute here, you can find the power input and efficiency. Like that, the n number of ways are there. Okay, you can follow any procedure. Is that clear? So here different formula in terms of V2, here in terms of A. Any procedure you can use it. If you use, you will get A is 0.02, efficiency is 0.9778, power input is the 491 kilowatts. Any doubt in this project? In terms of V2 or in terms of A, anything you can take it to solve this problem. Is it clear? Hello? Shall I go to the next problem or any doubt?
Okay.
Okay. Second problem. So if an aircraft of wing area S, okay, so this is the wing area and drag coefficient is CD, flying at a speed of V, that means this is free stream velocity. Okay, so instead of V1 they are given V, density is rho of a single air screw. Air screw also, it's another name of propeller. Okay, so air screw is the another name of propeller, don't forget. Produces the thrust equal to drag, and the speed in the slipstream velocity is Vs, that is V2 they mention as Vs. Using the Froude momentum theory, we have to prove this. So they have given the wing area, then blade area. Okay, S is the wing area, A is the blade area, CD is for drag coefficient, free stream velocity is capital V, slipstream velocity is Vs. Okay, this one how to proceed. So finally, we have to derive this. We have to prove the bottom equation. So how to start? How to derive this term? Any idea? Anyone? From which equation we can proceed? So you will start with this. Thrust is equal to drag, because thrust equation will have all this velocity term. Okay, and drag equation will have this CD. So if we can equate this thrust and drag, we can get this relation. Okay. So just given data, thrust is equal to drag, wing area, blade area, free stream velocity is V, slipstream velocity is Vs, blade velocity is Vb. This is the given data. So I'm equating thrust and drag equation. So thrust equation, if you take it is m dot dv. So instead of m dot, I can take rho a v v2 minus v1. Again, we don't know this blade velocity. So instead of this V, I am taking V1 plus V2 by 2. So this equation we can take it for thrust. Now apply to this control volume. What you will get it? Rho A. Instead of V1, V2, we will get Vs plus V. Okay. It is. This equation I am applying to the control volume, this control volume, so that I am getting rho A Vs plus V by 2 into Vs minus V. Okay, instead of V2 minus V1, I am getting Vs by V. This is one equation. The normal drag equation we know, just half rho V square S CD, wing area CD. Now equate these two. They can cancel drag, that is density, this 2 and this A you can bring it here, and this Vs plus V into Vs minus V, you can write it as Vs square minus V square. This V square also bring it to this side, so you will get Vs square minus V square divided by V square is equal to, I think, S by A CD, like this. Then cancel this, then you will get Vs square minus V square is equal to 1, then minus 1 is equal to this term, then minus 1 if you take, it will be 1 plus this term. Okay, then this V square if you take, it will be V square this term. Now Vs is equal to V into root of, like this you will get it. So that simplification I haven't shown, it is very simple only. Okay, simply I have taken the thrust equation in terms of V1, V2 alone, that I am applying to this control volume. Instead of V1 it is V, here it is Vs. Okay, V and Vs, you will get this equation. The normal thrust equation, equate and simplify, you will get this equation. Is that clear? Hello? Shall I go to the next one or should I repeat? So once this question was asked in 12 marks, mistakenly they asked this in 12 marks, but it is very simple, like 4 mark or 5 mark problem. Just two equation, thrust and drag, you can simplify, you will get the final term. The next one, a cooling fan is required to produce a stream of air. So instead of propeller, they have taken the fan. Okay, so there is a cooling fan. Assume in this direction it is blowing. So a cooling fan is required to produce a stream of air 0.5 meter in diameter with a speed of 3 meter per second. So this line is visible, right? To tell me this 3 meter per second is the free stream velocity or slipstream velocity, whether it is V1 or V2. Can you tell? They consider the fan. You know, the fan is blowing the air. It sucks the air and blowing with a very high speed. So what is this 3 meter per second? Whether it is V1 or V2? Akansha, Bettina, Bharati, Nisha Harwal. Anyone is there?
Yes, sir.
Can you say whether it is V1 or V2?
Sir, I guess V1.
So a fan is required to produce the stream of air. If fan produces the air, whether it will be in the upstream or downstream. This is the fan. This is producing the air with a velocity 3 meters per second. Okay, you know fan how it will work, right? It will suck the air from the atmosphere surrounding, and it will give it with a very high velocity, right? So the fan is producing a stream of air with a dia 5.5 meter with a velocity 3 meters per second. So this is V2. So fan also similar to the propeller. It sucks the air and pushing it to the very high velocity. Okay. So this 3 meters per second is the V2 slipstream. Is that clear? Should I repeat it? So fan producing the stream. Produce the stream means this only you consider it. This only it produces with a dia 0.5 meter and speed 3 meters per second. And it is operating in a region of stationary air. That is, in front it is stationary, from there it sucks the air. Assume the stream is fully developed. So the slipstream is fully developed. There is no mixing between surrounding, and we have to find what is this dia of the fan and what is the power input, power required. Who responded now? Bharatiya.
Sir, I responded.
So who is this?
Sir, Disha.
Disha. Good, at least you responded. Thank you. So for this problem, if you draw, so this is the fan which produces the stream of air with a 3 meters per second with a dia 0.5 meter. Once you know the dia, you can find the area of the slipstream. So we know area and velocity, and density is constant 1.225 sea level conditions, and they said it is operating in the stationary air. Okay, so initially the velocity is 0. Due to this rotation, the velocity will keep on increasing. Maybe in the beginning it is 0.001, 0.001, 0.01, 0.1, like that. It will reach. Either the velocity will increase. Behind that, it is further increasing and reaches the 3 meters per second. So this is the control volume. Okay. And we know mass flow rate is constant everywhere. You can find it at the blade or at the downstream profile, etc. and all. And what they are asking is blade dia and power input. First, we will see how to find the blade dia. So the simplest formula is mass flow rate, rho AV. Through that we can find the area, and then dia we can find it. So density is 1.225. So area only we have to find it, and blade velocity we don't know. Okay, mass flow rate also don't know. So first we have to find the mass flow rate, and you can see the slipstream. We know the area, we know the velocity, we know the density, and substitute here rho 2, A2, V2, we can find the mass flow rate. And this mass flow rate is constant everywhere. Then we can use that mass flow rate value here. From there you can find the area, then dia. Okay, this is the first step. So whenever they ask area, you should first take mass flow rate equation. Okay. So here we know all the values in the slipstream condition. So I am finding mass flow rate first in the slipstream using this velocity, area, density. First I am finding the slipstream mass flow rate 1.225. Area also we found velocity 3 meters per second. From this I am getting this mass flow rate. Once you know this mass flow rate, then we can go for the blade profile, that is blade section. So same mass flow rate, density, area, velocity. This velocity also unknown. So I am going to find using this formula V1 plus V2 by 2. Actually V1 here I have considered as negligible. because they said it starts from the stationary air. But if you draw the control volume, we cannot start with the zero velocity. We have to consider some minimum velocity. Okay, there should be some flow. Then only we can consider the control volume. We cannot consider at the zeroth level. So I'm taking some minimum velocity 0.001 or 0.001 something, 001 or 001. So in that case, I'm considering the velocity is negligible. Okay. So we should not consider control volume from the zero velocity. So I'm considering from some minimum velocity. So there is some negligible level, 0.001 or 001 or 0.01. So instead of V1, I'm taking just negligible value. Even if you take also, it will be P plus 0.00001. It won't vary much results. So V1 is negligible. We know V2, then V2 divided by 2 will give you the blade velocity. So once you know the blade velocity, substitute here. So we know density, we know velocity, blade velocity, we know molecular rate. From that, you can find the A value. Once you know the A, you can find the dia, pi d squared by 4. Okay. This is the first step to find the dia. Is that clear? Sorry. So whenever they ask diameter or area, first you have to take the molecular rate. And to find the molecular rate, we know all the known conditions in the slipstream: area, velocity, density. So using that, first I'm finding the molecular rate in this section. Then use the same value at the blade section. But we know we have two unknowns. First I'm finding the blade velocity. So I'm assuming the free stream velocity is negligible. So first I'm finding blade velocity. From that I can find the area. Then I'm finding the dia. Okay. Then power input. Okay, so now you can tell which formula we can use it for power input. Anyone? How to find power input? Oh, I'll close the PPT. So, okay. Okay, so for power input, I can use thrust into blade velocity. Okay, so thrust is m dot dv, that is m dot v2 minus v1. So power input is thrust, that is m dot v2 minus v1 into v. V just now we found it. This 1.5 meter per second. M dot also we found 0.7212, and V2 is given 3 meter per second. V1 is negligible. Substitute everything, you can find the power input 3.24 watts. Is that clear? I have only 3 problems. So like that, in this momentum theory, only few formulas are there. Just thrust formula in 2 different forms, maybe 3 different forms. Then blade velocity, 2 different forms. Then efficiency, that is in 3 or 4 methods, in terms of A, in terms of thrust, or in terms of V1 plus V2. So using these formulas alone, so you can solve all type of propeller problems. Okay.